Okay, so in this video, we're going to briefly just go over electron configuration and orbital notation. So we're going to be looking at our energy levels and where we put our electrons, and so dealing with our S, P, D, and F levels. So this is going to be just a little bit of a refresher just for you and to kind of see some examples. So hopefully this kind of helps you out. Okay, so when we first look at our periodic table, we're gonna actually separate this up into our groups. Okay, so our first energy level is called our S energy level. So these left two columns is our S energy level. So that's our first one, and it can hold 2 electrons. Okay, if it has 2 columns, it can hold 2 electrons. Our next energy level is going to be our P level. Okay, so we have our P level right here. That can hold 6 electrons. Okay, if I have 6 columns in my P group over here, it can hold 6 electrons. Then I have this middle section. Okay, this is going to be our D level. Okay, and it can hold 10 electrons. Okay, it's got 10 columns, so 10 electrons. So lastly, we have our F level, which is down here, and it can hold 14 electrons. Okay, so when we're doing our electron configuration or orbital notation, I always remember the phrase, read it, so read like a book. Okay, and so the way we read a book is you read one sentence from left to right, then you go down to the next sentence, read left to right, then down to the next sentence. So we're going to be following this same principle here. Okay, so a real quick little tip is when you see these numbers over here to the left, okay, S and P will follow those numbers. Okay, so follows numbers. Okay, so 1S, 2S, 3S, okay, they will all be the same as the numbers on the side. Okay, 2P. So real quick, I'm going to write it on here. So I have 2S, 3S. I have 2P, 3P. Okay, so it's going to follow those numbers on there. And I'll erase these here in a second, so it's just kind of a little bit for notes. Then I get to D. D is always one behind. So right here where you have 4S, this is actually going to be 3D. Okay, so this whole row right here is going to be 3D. Then I get back over here to my P, and it's going to go back up to 4P. Okay, so if it's 5S, it would be 4D. Then back up to 5P over here. So D is always one behind. F is always 2 behind. Okay, so 2 behind. So I have 6S right here. Okay, and if you see this little line that's dragging you down to the bottom, that is actually going to take you down to the F level. Okay, so if I was going to go from barium, okay, so barium has atomic number 56, then how it jumps to 71, so I've got that gap in the middle, so I've got to go down here to 57, starting with lanthanum. Okay, so F is going to be 2 behind, so this whole row is going to be 4F. Then, if I have to go all the way through this row, it's going to take me back up here to 5D. Okay, so 6S to 4F to 5D. So we're going to do some examples where hopefully this will kind of make some sense. So I'm going to clear off a lot of this. If you need to rewind it, that's fine. So that's just a brief little touch-up or notes on that. So we're going to clear this up. Okay, make some room. I'll probably still leave some of the stuff to the side. So let's do some examples. So on my mixed practice worksheet, I'm only going to do a few of these. I'm not going to do all of them. Okay, so extended electron configuration. So first of all, extended means you have to start at 1 every time. Okay, noble gas notation, that's when you start the last noble gas. So we'll cover that in just a second. So remember, electron configuration is where you use, oops, let me get back to my marker, is where you use exponents. Orbital notation, so you got to think of it arrows going up and down, make an orbit. Okay, so orbital notation will be the arrows. Okay, so you have to know the difference between those two. So I'm gonna kind of come out of the box a little bit on this because it's a little harder to do this on an iPad, and then I'll erase it. So feel free to rewind it if you need to. So magnesium, first thing I'm gonna do is I'm gonna find magnesium on my periodic table. So magnesium is going to be right here. Okay, so protons and electrons are always gonna be equal unless there's a charge. So magnesium has an atomic number of 12, so therefore I have 12 electrons to work with. Okay, so first thing is I have to get to magnesium right here. So we're gonna read it like a book. So we're gonna start from the beginning. Okay, so we gotta go through 1s first. So even though helium is over here to the right, just for this sake, I'm gonna bring it right over here because helium is a part of this 1s group. Okay, so I have to go through 1s, so I'm gonna go all the way through it. So that means 1s is full. So you're gonna put 1s2. Okay, there's nothing left on row 1, so now I gotta go down to row 2. I've gotta go through lithium and beryllium. Okay, so I'm still trying to get to magnesium. So that was 2s. Okay, so that one's gonna be full. So it's gonna be 2s2. Okay, then my next one is gonna be 2p. Okay, so I gotta go all the way through 2p, so that one's gonna be full. So p holds 6, so you're gonna put 2p6. Then lastly, now I'm on 3s, and magnesium is where I stop. So right there on 3s2, so my final part would be 3s2. Okay, and that's it. That's all you gotta do. So extended orbital notation, so now instead of exponents, we're just gonna do arrows instead of numbers. So you're gonna draw 1s. So remember, s can only hold one pair, okay, or 2 electrons. So we're gonna draw a line, and you're gonna have an up arrow and a down arrow. Okay, so this follows Pauli's exclusion principle, is if you have one arrow going one way, the other arrow has to be going the opposite way. Okay, then, so we're done here with 1s. So now we're gonna move on to 2s. So we've got 2s, we're gonna draw our line, s can only hold 2, so I'm gonna do an up arrow and a down arrow. Okay, so we're done with 2s. Then we gotta go into 2p. So 2p, I'm gonna write this, p can hold 6, so that means we're gonna have 3 pairs. So you're gonna draw 3 lines. Okay, so if I have 6, I'm gonna fill it up. So 1, 2, 3, 4, 5, and 6. Okay, so done with 2p6. Now I've got 3s2 to do. So I'm gonna type 3s. I'm gonna write out 3s. S can only hold 2, and I'm at 2, so now I am done. That's it, all you gotta do. Okay, so if you need to see this, I'm gonna have to erase this one to make more room. Okay, if you need to see this, feel free to rewind it. So I'm gonna clear this up. Okay, noble gas electron configuration. So noble gas electron configuration is the shortcut. Okay, so let me clear up some of this stuff. Okay, right over here, this whole group, this right column is your noble gases. Okay, so the trick is you're gonna find the noble gas right before where you're trying to get. So what was the last noble gas before you got to magnesium? So magnesium is number 12 right here. So my last noble gas would be neon. Okay, so what we're gonna do is we're gonna put neon in brackets. Okay, so we're gonna use that as a starting point. So neon is now gonna take me back down here. So my starting point now is gonna go down to 3s. So I don't have to worry about the 1s, 2s, 2p. Okay, when you told me neon, I'm assuming that you already know that we went through 1s, 2s, 2p. Now we're gonna start at 3s. Okay, so you're simply gonna put 3s2. And that is it, all you gotta do. So for noble gas orbital notation, so same thing. So we're still gonna put neon in brackets. And instead of exponents, we're just gonna do 3s, and we're gonna do our arrows. Okay, that's it. So we're gonna look at electron dot. So electron dot is when we count the number of valence electrons. Okay, so there's 2 ways you can do this. So one, you can count up your highest, so So for electron dot, so one, you can count the highest S and P level. So count the highest S and P level electrons. Okay, so my highest S level would be 3S. There is no 3P in this one, so I don't have to worry about it. So that means it would only have 2 valence electrons. So that is one way. The second way is to look at the group number. And what I mean by group number is I'm going to go up to this periodic table. Okay, let me clear off some of this stuff to make it a little more organized. Okay, our group numbers is going to be this 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. If it falls on one of those groups, one of those columns, that is your number of valence electrons. Okay, so magnesium is right here. So it falls under the group 2A. Okay, so it has 2 valence electrons. So that's one way of doing it. Okay, if you're not going to do the S and P. Okay, this whole D section, the last group name 2A was the one, the last group before the D level would be 2A. So that means this whole D level is going to have 2 valence electrons. Okay, so that is one way to remember it there. Okay, so now what we're going to do is now we know there are 2 valence electrons. So we're going to write the abbreviation for magnesium. So that would be Mg. Okay, so I have 2 electrons, so I'm going to have 2 dots to do. Okay, so you're going to always start at the top and draw a dot, your first dot. And then you're going to go clockwise until you finish with your number of dots. I only have 2, so my next one's going to be right here. And that is going to be it. Okay, that would be your final answer. Okay, so that was the first one. So let's try another one. So we're going to try to do vanadium. Okay, so vanadium is right here. So number 23. So vanadium has 23 electrons. Okay, so we're going to start. So we're going to start off with extended electron configuration. So we're going to start at the top, the beginning. Okay, so let me clear off some of this. Let me put this helium right here, and this was their S level. Okay, so we're going to start off at hydrogen, and I'm trying to get to vanadium, so I got to go through 1s. Okay, so 1s2. I filled it up. Done on level 1, so I'm going to go over here to level 2, so I got to go through lithium and beryllium. So that means 2s2 is filled. Okay, my next level is going to be 2p. So 2p right over here. So I got to go all the way through it. So that one's going to be full. So we're going to write 2p6. Okay, now I'm on 3s. I've got to go all the way through it. So 3s is full. So it's 3s2. Okay, then I got to go through 3p all the way through. So I'm going to write 3p6. Okay, now I'm on 4s. Okay, I got to go all the way through it, through potassium and calcium, so 4s2 is full. Okay, so here's where you got to be careful. So do not say it's 4d. So remember, d was always 1 behind. So when it's 4s, the next d is going to be 3d. So you're going to put 3d, but I only went 1, 2, 3 into my d level. So you're going to put 3d3. Okay, and that is going to be your answer, an extended electron configuration. Okay, so we're going to do the extended orbital notation. So even though selenium is right below it, I'm going to use this space right below just so I have some room. Okay, so I'm going to do extended orbital notation. So I'm just converting to arrows now. So 1s can only hold 2 arrows. Okay, so I'm going to fill that up. Then I have 2s. Okay, 2s2, so that one's going to be filled up. Then I have 2p. So remember, p has 3 lines. It can hold 6. So 1, 2, 3, 4, 5, 6. Okay, so we're done with 2p. So now we're going to move on to 3s. So so it can hold 2. So that one's going to be full. Then we have 3p. So that one's going to be full, so I've got 3 lines for 3p. So I'm going to fill that up. So 1, 2, 3, 4, 5, 6. So now I got to move on to 4s. So that one's going to have 2 arrows in it, so that one's full. Then I get to 3d. So remember, D can hold 10 electrons, which would be 5 pairs. So you're going to write out 3D with 5 lines. 1, 2, 3, 4, 5. Okay, so I only have 3 electrons to do here, so 3D3. So I'm going to draw 1, 2, 3. Okay, so this is Hund's rule. Okay, so Hund's rule states that these electrons will spread out before you stack them. Okay, because you got to remember they're negatively charged, so they don't want to be near each other because they're going to repel each other. Okay, so they will not stack until they have to. Okay, so that was our answer in extended orbital notation. So now we're going to do our noble gas electron configuration. Okay, I'm going to do that right below that, and then I'll clear all this up. So that's just kind of here for you to see. Okay, so we're going to go up. So vanadium is number 23. So my last, let me clear up some of these lines real quick. My last noble gas before vanadium would be argon, number 18. Okay, so you're going to write argon in brackets. Okay, so argon, so now we're going to start at 4s. So we're going to go through 4s. So you're going to do 4s2. Then I go into my 3D level. So that was going to be back on, so 3D, and I only went 3 in, so 3D3. So that's it. Okay, so our noble gas orbital notation is just the same thing, except we're just going to use arrows. So AR is still going to be in brackets. 4S is going to have its arrows now. Okay, so 4S2, so that one's full. Then I'm going to do 3D, and 3D is going to have the 5 lines. So 1, 2, 3, 4, 5, and only 3 arrows. 1, 2, 3. Okay, so vanadium, so now we need to do an electron dot, so we need to find the number of valence electrons. So if you count the highest S and P, okay, so only S and P, do not do D, because remember D can hold 10. Okay, so real quick up top, your max number of valence electrons is 8. Okay, so if you start counting those D's, you're going to quickly get past 8. So it's only the top S, the highest S, and highest P. So I don't even have a P, so I don't have to worry about that. So this 4S has 2. So that means I have 2 valence electrons. So vanadium, we're going to abbreviate V. I have 2 valence electrons. I'm going to start at the top, count 1, then go clockwise, 2. So that would be my answer. Okay, so that is how to do all of those methods. Okay, so we'll do one more. Okay, just to kind of give you some practice, we'll do a long one just so you can see that. Okay, so I'm going to clear some of this stuff up. So again, if you need to see this stuff, again, just rewind it and pause if you need to. So let's pick a good one. So we're going to pick iridium. Oops. Okay, so this one's going to be a long one, so just kind of bear with me on this. Okay, so this is kind of just good practice to see how well you know your energy levels. Okay, so we're trying to get to iridium. So we got a little bit of a ways. Okay, so first thing we're going to do is we're going to do extended electron configuration. Okay, so we're going to start at the top. We got to go through 1s. We're going to go through it. Okay, so 1s2. Okay, then we got to go through 2s2. And while we're there, so I don't have to scroll back and forth so much, I'm going to say we're going to go ahead and go through 2p6. So we're done with our 2 level. Okay, so we went through our 2s2, and we went through 2p6. Okay, so now we're going to go back up. So now we're going to go through our 3s level and our 3p level. Okay, so those are full. So 3s2, 3p6. Now we're going to go back up. We're on our 4s level. We're going to go through 4s. Then we're going to go through 3d. And then right after 3d, this jumps back into 4p. So remember that s and p follow those numbers to the right, to the left. Okay, so we're going to go through 4s, we're going to go through 3d, and we're going to go through 4p. Okay, so we're going to go through 4s, so that's 4s2. We're going to go through 3d, so that's 10. And we're going to go through 4p, which would be 6. Okay, so now we're going to move on to 5s. So we're going to go through 5s, we're going to go through 4d, and we're going to go through 5p. Okay, so we went through 5s, so 5s2. Then we went through 4d, that holds 10. And then you have 5p with 6 valence electrons. I'm sorry, just 6 electrons, don't worry about that. Then we're going to go through 6s, so 6s2. Okay, this is where you got to watch out for the line. So it jumped from 56 to 71, so that now I'm going to go down here. Okay, and now this is my 4F level. Okay, remember F is always 2 behind the numbers on the left. Okay, so this whole level right here is my 4F. I'm going to go all the way through it. Okay, and 4F can hold 14.
Pep rally is still happening. Bundle up and join us at 5:30 in the stadium to cheer on
still having the pep rally.
We will announce the nominees and winners of this year's 2020 homecoming court and watch some great performances. Students will be sitting in the center section of the stadium. Wear your mumps, masks, and costumes and jackets. We're excited to see y'all there.
All right, so there's an announcement. Apologize for that. So homecoming is still on. So we went through 4F. So that was 14 electrons, so 4F 14. Now we're going to come back up here and start back at 71, which is 5D. And we're going to go 1, 2, 3, 4, 5, 6, 7 in. Okay, so this is going to be 5D 7. So 5D 7. And that is your extended electron configuration. So that can get tedious. Okay, so this is good practice to know your energy levels. Okay, orbital notation, you can figure this out. Okay, so just know that when you go through into your S, so 1s is going to have 2 electrons. When you get to a P, okay, so let's just say 2P, that's going to have 6 electrons, so 3 lines. So that would be full. Okay, when you get to D, you're going to have 5 lines, so 1, 2, 3, 4, 5. Okay, and that would be full, so we would fill that up. Okay, and then when you get to F, F can hold 14. Okay, so that's 7 pairs, so you're going to draw 7 lines. So 1, 2, 3, 4, 5, 6, 7. Okay, so if you're going to fill it up, you would fill up everyone with arrows. Okay, so just for an example, if I only had to go like 5 into F, you're still going to draw the 7 lines, but you would only count 1, 2, 3, 4, 5. Okay, so you're still going to draw those 7 lines, but you're only going to fill up 5 of them with 1 arrow apiece. Okay, so that was just kind of a little tip for you there. Okay, so that is how you do the orbital notation. So that is a little bit tedious, and I'm not going to go through that, but just make sure you get the correct number of lines. Okay, so if I were to do noble gas shortcut. Okay, so let me clear up some of this. Okay, so my last noble gas before iridium would be xenon right here. Okay, so we would do xenon in brackets. Okay, so I'm going to start after xenon, so that means it's going to take me to 6s. I'm going to have to go through 6s. So that would be 6s2. Then I jump down here to my 4f. I'm going to go all the way through it. So 4f, oops, sorry, my stylus messes up. 4f, 14, because I went all the way through it. Then I'm back to 5d. So I would go through 5d. So 1, 2, 3, 4, 5, 6, 7. So this would be 5d7. Okay, so that would be the noble gas electron configuration. Okay, the orbital notation is you're just going to switch the exponents and you're going to use arrows now instead of the numbers. Okay, so let's look at electron dot. Okay, so we want the highest S and highest P. Okay, so 6S is going to be my highest S, and I don't even have a 6P. Okay, so I don't have to worry about that. I'm not going to worry about 4F14, not D7. Okay, because remember the max number I can have is 8. So only S and P. So I only have 2. Okay, so that means Iridium, we're going to abbreviate it IR. I only have 2 valence electrons, and that is going to be 1, 2. Okay, so real quick, let's do an example of electron dots that don't have 2. I know every example I've chosen has 2, so we'll just do a quick example. So if I did phosphorus, right here, it has a group number of 5A. Okay, so what I would do is I would do phosphorus with a P. I would have 5 dots starting with the top. 1, 2, 3, 4. I have 1 left, so this is when you start doubling up. So you're going to put 1 more back on top. So that would be how you would do phosphorus. Okay, if we did chlorine, chlorine has 7 valence electrons. Okay, so chlorine would be Cl. I have 7 dots, so 1, 2, 3, 4, 5, 6, and 7. Okay, so that would be what the electron dot diagram would look for chlorine. Okay, so that is how you do multiple valence electrons, and they just double up whenever you get back to the top. Okay, so hopefully that kind of helped you out a little bit. So let us know if you need any help, and feel free to rewind this, pause it, and stuff. I know I wrote a lot, so this is here for you to use. So hopefully this helped.